Diatomic molecules, molecular orbitals in diatomic molecules. Diatomic molecules. Diatomic molecules means nitrogen, diatoms, like diatoms, oxygen, O2, diatomic. Yes, F2, diatomic. How to splitting of electrons? Generally, electronic configuration, you know, what is the oxygen electronic configuration, what is the nitrogen oxygen configuration, what is the fluorine oxygen, configuration, electron configuration. But here is how to splitting. We find out the character, magnetic character, or paramagnetic character, or other magnetic character. We should calculate by using participate electrons. How to participate electrons? How to participate electrons in the orbital? We have bonding orbitals, anti-bonding orbitals. We have bonding orbitals, anti-bonding orbitals, right? Main conditions for formation of molecular orbitals are approximately the same energy, two oxygen molecules, same energy, right? How to splitting the electron? Matching symmetry, approximately the same energy, and positive overlap to the bonding orbitals. And other one is, yes, this is the energy levels, bonding, anti-bonding orbitals. We should calculate like this, right? Atomic orbital, 1s, 2s, 2p, 2p. These are the, yes, this is the energy increasing levels. Already, you know, increasing levels means higher energy levels. Higher energy level means 1s, 2s, 3s. More energy, 1s is 2p greater than 2s greater than 1s. These are the energy levels increases. Okay, downwards means what? Lower energy, more stable. Like these are the more energy. Yes, more stable, less energy. Here is, yes, more energy, less stable. This is the energy graph, energy diagram. Right. Here what happens? Splitting of electron. How to splitting of electron? First 1s is splitting, S next 2s, next 2p. Here you take SO2 or N2 or F2. Yes, here two atoms participate. Here 1s is existed 2 electrons, here 2 electrons, here 2 electrons, here 2 electrons. Here 2p means 2 electrons, 2 electrons, 2 electrons, 2 electrons means we get different electrons in different orbitals. 1s orbital, 2s orbital, 2p orbital. You find out 1s, that is the 1s, that is the what is the sigma 1s bond. This is the sigma 1s bond is formed. This is the sigma 1s bond. The 1s minus 1s. This is the 1s minus 1s. This is the anti-bonding. Sigma star 1s. These are the participate here. One electron is here, one electron here. Yes, here is sigma 2 star is no electron. Yes, one electron from here, one electron from here. Here splitting. Other electron is jump to higher energy. Higher energy, low stable. Higher energy, low stable. Same thing we can discuss here. Yes, 2s, 2s, 2s minus 2s. 2s plus 2s. One electron from here, one electron from here. One electron is what happened. Here splitting the electron. Here splitting the electron. One electron from here, one electron from. 2 electron is splitting the air. These are the lower energy, more stable. These are known as sigma 2s bonding orbital. Sigma 2s bonding orbital. Another electron splitting sigma star 2s. One electron from here, one electron from here. These are called as sigma star 2s. Sigma star 2s. This is the important thing. Sigma star 2s. Next is 2pz. 2pz, 2pz, 2pxo, 2py. Yes, 2px, 2py, 2pz. Here splitting the electron. Here splitting the electrons in orbitals. Bonding orbitals, ending bonding orbitals. How to splitting we can see. How to splitting the electrons, right? How to splitting the electrons. How to splitting the electron. Here is 2px, 2py, 2pz. Here 2px, 2py, 2pz. Like this. We are yes participate electrons. How to participate electrons? Right? 2pz to 2pz, sigma 2pz, 2pz minus 2pz, sigma star 2pz. Another electron is pi, pi star. One electron from here, one electron from here. Yes, it is filled. Here it is called sigma 2pz. Are you able to see this one? Yes, guys?
Yes, sir.
Yeah. Thank you. Right. This is the diagrams of diatomic molecule splitting of electrons in bonding and anti-bond. See, here very simple. Next is 2p, yes, 2p, x, 2p, y, 2px, and one more electron is splitting here, one more electron. This is called pi 2p, x, pi 2p, y, same energy levels. This is the same energy level. This is the same energy, 2px, 2py, 2px, 2py. Yes, sigma, not sigma, pi 2px, this one. Next, pi 2py, this one. Like anti-bonding. Anti-bonding at a star. That pi star 2px, pi star 2pz. We have 6 electrons here. We have 6 electrons here. Now splitting. Splitting first is 2pz is splitting here. One electron from here, one electron from here, splitting over. And the other one is 2px, 2px. Remaining one more electron is, yes, higher energy levels. 5 sigma star 2pz. Sigma star 2pz. Now filling here. Now remaining is what? 2px, 2py, 2px, 5 star, 2px, 5 star, 2p. Why? Now we are splitting. These electrons are splitting like this. These are all are. These are not star indication is anti-bonding participate electron. Now here this is bonding, this is bonding, this is bonding. These two, yes, these two are bonding. Remaining is what? This is star indication is anti-bonding. How many electrons in anti-bonding? Sigma star 1s. How many electrons in sigma star 2s? How many electron is 2p? 5, yes, 5 star, 2px 5 star, as 2p, as 2py 5 star, like 5 star, 2px, 5 star, 2pz. Another one is 2pz. These are the order also. These are the order. Energy levels are what? Here more energy. Here anti-bonding is more energy. Anti-bonding is more energy. Anti-bonding is more energy. Anti-bonding is more energy. Anti-bonding is more energy, less stable. Anti-bonding is more energy, less stable. Anti-bonding, here is what is the 5 star 2px, 5 star 2py. Anti-bonding is less stable. Here is anti-bonding less stable. Why less stable? More energy, less stable. We are discussing previous case. The repulsive of nucleus, that's why the electron is jump to higher energy of orbitals. Higher energy of orbitals. Why you are draw this diagram? Your question is what? Why you are draw the diagram? You know the configuration 1s2, 2s2, 2p3, that is nitrogen, 2p4, that is oxygen, 2p5, that is the neon. We know all those electronic configuration. Why? Why means we should calculate bond order, how much density of electrons, how many density of electron, right? And another one is bond order. How many bonds are there? Double bond, single bond, triple bond. A bond is very, very important. Bond. Yes, bond is very important. Yes, cleavage the bond, attach the one more molecule. But suppose polyethylene, ethylene monomer. Yes, ethylene monomer is how many bonds are there? Double bond is there. Break the bond, and attach the one more monomer. Ethylene monomers to combine to form the Big molecule, that is a polythene. మన చేతిలో ఉన్న polythene paper. We are regularly use the polythene paper, polythene bags. That is very simple. Without breaking up that bond, we cannot prepare the polythene like polystyrene. Yes, we are wearing shirts, different type of jeans and shirts, and wearing of goggles. Right? How can we form these all materials that break the bond, attach the one more monomer? Without formation, yes, no material is formed. No bond, no formation of the molecules, no formation of the product, no formation of the material. Do you know PVC pipes? How to form the PVC pipe? CH2 double bond, CH, yes, chlorine, PVC, chloride, C ki, CHCl, CHCl. Now adding up different monomers. Now break the bond. Where is the bond is? CH double bond, CHCl. The double bond, one bond is breakdown, attach the one more new monomers. That is from the PVC pipes. Do you know PVC pipe? More application. And why should read this one? Why should the bond formation? Why should double bond? Why should triple bond? What is the role of bond? We know role of bond means making different type of materials. Otherwise, how can you establish the material? As an engineer, you should be think about like this, not chemistry like this. Yes, bond importance is why. How to splitting bonding orbital, how to splitting anti-bonding orbital. These are the very important of the molecule. Very important of the molecule. Do you know what is the important of oxygen nowadays? Yes, how to splitting of electron? What is the configuration of electron? 1s2, 2s2, 2p4. Right. Okay, how to, what is the bond order? How can you find out? Now, this is the molecular orbital in diagram, diatomic molecule. Then now is the anti-bonding electrons minus anti-bonding, bonding electrons minus anti-bonding electrons. Cheste manaki by 2 cheste, we'll get the bond order. Where is double bond? Where is single bond? Where is triple bond? We should calculate and we find out the character of the molecule. What is the character? It is a paramagnetic, diamagnetic. What is the color is observed, exhibited? We should find out the in universal any compound in universe, any compound, any polymer or materials or nanomaterials and electrical materials or insulate material. We should be calculate of the character of the these all things. That is the important thing, right? Okay, now splitting is this is the bonding, this is the bonding, this is the bonding, this is the bonding. That's why now splitting is first this one splitting one electron from here, one electron from here. Now we can see that how to splitting of the electrons here. How to splitting of electrons? This is the first. This is the electronic configuration is what higher energy. Sigma 1s. This is the less greater than sigma star 1s, s less than, and sigma 2s less than sigma star 2s s. This is the bond order like less than sigma 2pz. Not right. 2pz is first. Next less than 2px. 5 2px equal to 5 2py. Both are in same energy levels. 5 2px equal to 5 2py are the same energy levels. Less than 5 star 2px equal to 5 star 2py. Why? These are the same energy levels. Next, last one is the higher energy, the sigma star 2pz. Sigma star, this is the higher energy, less stable. Higher energy, less stable. That's way. Yes, this is the bond order of the molecular orbital theory. We can apply like this. Yes, we are. Do you know Abbo principle state that orbitals of less energy levels will be occupied by electrons first. The lower energy, this is the lower energy. Next one, this is lower energy. This is that. That's why lower energy first electron is filled, then higher energy. 1s sigma 1s is first filled. This is first fill, next this one. This is next fill, this one, next this one, next this one, next this one, next one. Like both are same. Both are same. Yes, these are the both are same. These are the both are same. Next this one is filled. This is the energy level. First, this is the energy distribution of electron in the molecular orbital is on the basis of Abbo principle. What is the principle? Abbo principle. Abbo principle, how to say Abbo? What is the principle of Abbo? Yes, first electrons are filled in lower energy, then higher energy, then higher energy. That is the important thing, right? This is the filling of the electron. This is the filling of the electron. Okay, filling of the electron, right? Okay. Another one is, okay, this is the energy levels. Okay, electron density we calculated, bond order is calculated, and bond order is must be calculated based on bond order. We should calculate the character of the molecule. Character of the
Excuse me,
molecule.
sir.
Yes. Are you?
సార్ చాలా మందిని క్లాస్ లోకి అలౌ చేయలేదంట సార్.
అందరూ ఎలా అయ్యారమ్మా? 63 are inside. 63 members, right? 63. మీరు ముందు రావాలి. ఏదో హాఫ్ అన్ అవర్ తర్వాత వస్తాం, 10 నిమిషాల తర్వాత వస్తాం, రైట్? Time to time come, right? Right. Thank you. Okay, everyone in the class, 61 members are in the class. Thank you. Okay. Okay, this is the bond order. What is the bond order? Number of electrons in bond. Yes, bonding orbital. Number of electrons in bonding orbital minus number of electrons in anti-bonding orbital by 2. That is the bond order. Number of electrons. Okay, suppose here is how many electrons in bond order. Bond order calculation, bond order equal to number of electrons in bonding orbitals minus number of electrons in anti-bonding by 2. That is, we calculate the bond order, right? The bond order 1, suppose bond order is 1, the molecule have what? Single bond. The bond order is 2, the bonds between the atoms 2. The bond order is 3, the bonds between two atoms 3, like this. Okay, we should calculate a different type of bonds in different molecules, right? I will repeat again. Yes, this is the energy level diagram. This is the energy level diagram. This is the increasing order, 1s, 2s, and 2p. This is the increasing order, right? This is the, we can write like this: 1s, 1s, 2s, 2s, 2p, 2p. Here 1s 2 electrons. This side is 1s has 2 electrons. This is 2s 2 electrons. This is 2 electrons. 2p, 2p. 6 electrons. Here 6 electrons. Now splitting. First splitting in bonding molecular orbital. Bonding molecular orbital means 1 electron, 1 electron. Next, another electron is jump to anti-bonding. Next, one more electron from this side, one more electron this side. Remaining 1 electron is here, one more remaining 1 electron. Now splitting first is lower energy, higher stable. That is the bonding orbitals. Yes, higher energy, lower stable. That is the anti-bonding orbital. Anti-bonding orbital. That's very important, right? Very, very important of the bond order. This is the bond order, 1s, 2s, 2. This is the bond order. This already we discussed about sigma 1s. How to write these? Sigma 1s less than sigma star 2s. Like we can like this is the increasing order of the s molecular orbitals. Increasing order of the molecular orbital of the molecules. For examples, O2. How to splitting O2? What is the electronic configuration of O2? 1s2, 2s2, 2p4. Okay. Now this is here is 1s electron, here 1s electron, here 1s electron, here 1s electron. Now splitting. Yes. Suppose O2. Do you know O2? O2. Do you know O2? O plus O. O plus O. Do you know O2? Oxygen. O plus O. What is the electronic configuration? Do you know electronic configuration? Anybody please? What is the electronic configuration?
1s2, 2s2, 2p4, sir.
Very good, very good. Here is 2 atoms are there. O plus O, O2. Here this side, same thing. We can write like this. Here 1s2, 2s2, 2p4, like, okay, 1s2, 2s, right? Okay, we can write like this. How can you write the, suppose 1s2 electrons, 1s2 electrons, one electron from this side, 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 fill in. Like 2s, 2 electrons, one electron here, one electron, fill the orbital. Another electron is fill this here, fill this here, right? Now remaining 4 electrons, 1, 1, 1. First fill the single electron, then let's fill the pair. One electron, one electron, one electron. Next fill this one. Okay. Now splitting one electron from here, one electron. Right, one electron here, one electron. Another electron is, how many electrons are there? Here is 8 electrons are there. Here is 4 electron, here is 4 electron. How to filling here? One electron from this side, one electron. Yes, 8 electrons should be electrons so, and here, but 6 electrons, remaining electron, one electron, one electron, like this, right? This is the pairing of electrons in bonding and anti-bonding. We discuss the other diagram also. Yes, this is the bond order calculation, right? Bond order calculation. Okay, how to calculate bond order? Bond order equal to number of bonding orbitals, number of bonding electrons minus number of anti-bonding electrons by 2. If the number of bonding electrons greater than number of anti-bonding electrons, the molecule is more stable. More stable means whenever it is more bonding orbitals filling is more, that molecule is more stable. That molecule is more stable, right? That is the important thing, right? This is the molecular orbitals in diatomic molecules like O2 and 2. Yes, this is the important thing, right? This is the important one. Another examples, we discuss about different type of examples. Diagrams. O2, how to calculate it, O2. We see O2, N2, F.